This is a very compact waveform generator, and you will be surprised that this is a 2-channel waveform generator. Now you can imagine that when analog oscilloscopes what we were working earlier days, when I was doing my engineering in 89-90, so there were some of bigger size, but when it comes to digital storage oscilloscope, then the oscilloscope become compact. Similarly, you might have seen that the function generator, the analog function generators were of A4 size. But now when it converted into the digital, you can see that how compact this waveform generator is. It is a 2-channel waveform generator. And the beauty of this product is that most of the function generator uses a problem into the power supply which was built in. So here it works on an adapter. So you have to just plug in the adapter over here, and you can see that this adapter is connected over here. So this is the external power supply, which is a mains operated, definitely AC mains operated. So power supply is not internal. It is a normal AC adapter is there. Now you can see that it is a 2-channel waveform generator. So these are the 2 channel outputs, channel 1 and channel 2. So these 2 outputs are for channel 1 and channel 2. Now it is very simple to set this waveform generator. This is channel 1 window, this is channel 2 window. This is, if I want to select channel 2, I want to select channel 2, I can select channel 2 like this. If I want to select channel 1, I can select channel 1. If I want to channel 1 on, channel 1 will be on. If I want to do channel 2 on, then channel 2 will be on. Again, if I go back to channel 1, now I went to channel 1. Now, how many waveforms are there? It is a sine wave, square wave, pulse, ramp, arbitrary. Then if I go to next page, then noise and DC. So these are the different kind of waveforms which I can set it over here. And you'll be surprised that this waveform generator is 30 megahertz 2-channel. That is 30 megahertz 2-channel. The sine wave is 30 megahertz. Square wave is 15 megahertz maximum. Now you can see that frequency, if I want to set the frequency, if I go to select sine wave, now frequency I can set it from here. I can simply set it, I can select frequency. I have selected frequency 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. It is like that. I can select the frequency, or simply I can just move it over here and I can reduce it. Or if I want to set numeric keypad, I can use a numeric keypad. It is 1. I want to select 1 kilohertz, so it is 1 kilohertz. Even I can set a frequency like this 1.1, 2, 3, 4, 5, 6, 7, 8, 9 kilohertz. So I can set a frequency like this 1.1, 2, 3, 4, 5, 6, 7, 8 kilohertz. So this is what the frequency I can set. Similarly, if I want to set the amplitude, I can go here and I can set the amplitude. So it is a 20 volts peak to peak amplitude. So up to 10 megahertz, it is maximum, it is 10 volt peak, 20 volt peak to peak. And then you can refer the catalog as well. I can add offset, I can change the phase shift as well. So this 2-channel waveform generator is also useful because I can set 2 channels in a synchronized way. I can set frequency 1 kilohertz, channel 2 I can set 3 kilohertz, and then I can change the shape of the frequency ratio, and then I can use oscilloscope as a Lissajous figure, and I can show student that how I can measure the unknown frequency from the Lissajous figure or the phase difference. So this is what the product what we have. Now even if I go to the modulations mode, then you can see AM, FM is there, phase modulation is there, frequency modulation is there, and the frequency shift keying is there, and then the linear sweep and the logarithmic sweep is there. Again, if I go to into the wave, I can select the wave and I can sign. If I go to the, say for example, pulse, then right now the range selected is high, so I simply go to the, say 10 kilohertz. I will go and select the 10 kilohertz. Now I select the wave, I select the pulse. So this is a sine wave what I have selected. Now let me go here, let me select 1 kilohertz. Let me select the pulse. So I will just go selected a wave, then I have selected a pulse. So now this is my 1 kilohertz pulse. Now if I change the duty cycle, so I can set the 50% duty cycle. Now I can change it, that is a 60, 20%, 10%, 40%, 50%, 60%, 70%, 80%. So I can change the duty cycle from here. So these are the different waveforms what we have. So it's a versatile function generator what we are having. This waveform generator is also having a USB device connection. So you can see that I have connected this USB device to a USB port of my laptop. Now you see the beauty of this product. That on a laptop, the software window I have opened, it is a replica of the same waveform generator what I am having over here. Now a student can control this product through his laptop, through his computer. Say for example, want to select, right now the square wave I have selected. If I want to select sine wave, I can select from here the sine wave. You can see that sine wave on screen here. You can see that I have selected the sine wave. If I want to change if I want to go to the pulse, say for example this is a wave. If I go on to the say pulse, so now this is I have selected a pulse. Now if I want to change its duty cycle, I can change its duty cycle, I can change its volts peak to peak, frequency, anything. Say for example, if amplitude I want to change, if I want to select the duty cycle. So now I can set duty cycle from here. So if I want to set duty cycle 10, then I can select it is 10%. Then you can see that duty cycle has become 10%. If I want to select duty cycle to the 50%, then the pulse will be having the 50%. So you can see the control from here itself. So this is a very beautiful product what you get from here. Then I can switch it off from here. Now there is another thing which is a send command. So you get a send command window